that was a lot of a last video on divisibility and division, but we still have a lot more to talk about. So let's start this video on division by talking about some divisibility rules. Divisibility rules will help us to get a number feel for what the quotient is going to be before we actually start doing the long division. So first of all, you should know that any even number is going to be divisible by 2. An even number ends in the digit 0, 2, 4, 6, or 8. Digits in a number, if they add to a number divisible by 3, then the number is divisible by 3. If the last two digits of a number, greater than 99, are divisible by 4, then the number is divisible by 4. If a number ends in a 0 or 5, it's always divisible by 5. If a number ends in 0, it's always divisible by 10. And if a number is even and divisible by 3, that means its digits add to something divisible by 3, then it's also divisible by 6. So here are some examples of these, because just hearing those rules sometimes they don't make quite enough sense. So 28 is divisible by 2 because I can see that it ends in a 0, 2, 4, 6, or 8. Let's check it out. So 28 divided by 2, if you must, right? 2 goes into 2 one time, 2 goes into 8 4 times. Yep, sure enough. Let's check out if 1434 are divisible by 3 and by 6. Now, you might guess, oh yeah, sure, they're going to be divisible by, or you actually not guess at all. You may go, I don't think that's going to be divisible by 3, because sometimes our brain gets confused that if a number is divisible by 3, it's got to end in something that's divisible by 3, but that's not the case. So 1, 4, 3, 4. The check on this to see if it's divisible by 3 is let's add the digits. 1 plus 4 is 5, and 5 plus 3 is 8, and 8 plus 4 is 12. 12 is indeed divisible by 3, so this number should be divisible by 3. 3 goes into 14 4 times, and let me show you that short division trick again. So there's 14 minus 12, which is 2 left over. 2 and the 3 makes it 23, right? 7 goes into 20, or 3 goes into 23 7 times. 23 minus 21 is 2. And 3 goes into 24 8 times. And so you see it is indeed divisible. Now the kicker here is that this one should also be divisible by 6, because you see that this ends in a 0, 2, 4, 6, or 8, it ends in a 4, and it was divisible by 3. So that means that it not only should be divisible by 3, but because it's an even number divisible by 3, it should also be divisible by 6. 6 will go into 14 2 times with 2 left over. 6 will go into 23 3 times with 6 left over, and as a 6 now 5. Sorry, 5 left over, and 6 will go into 54 9 times. And you see it is indeed divisible by 6 as well as 3. Now the next one, we have 732 divided by 4. So we see the last two digits here are divisible by 4. So that's what tells me that this number should be divisible by 4. So 4 will go into 7 one time with 3 left over. 3 goes into 33 8 times with 1 left over. And 4 will go into 12 3 times. And look at that, evenly divisible. 2540 divisible by 5. Well, I see that it should be divisible by 5 because it ends in a 0, right? And that also means, by the way, that it should be divisible by 10. So it ends in a 0. Let's check it out and see if it's divisible by 5 and by 10. So I divide this by 5. 5 goes into 25 5 times. 5 times 25, or 5 times 5 is 25, so there's nothing left over. 5 will go into 4 0 times. 0 times 5 is 0. 4 minus 0 is 4. So we have a 4 left over. 5 will go into 40 8 times. Look at that. Absolutely divisible by 5. Now let's check out and see if it's divisible by 10. 2, 5, 4, 0. Divisible by 10 or not. 10 will go into 25 2 times with 5 left over. 10 will go into 54 5 times with 4 left over. And 10 will go into 40 4 times. And so it's absolutely divisible by 4. Here's a little trick for you as well. When you divide numbers by 4, you can take by 4. When you divide numbers by 10, you can take the decimal place and you can move them to the left the same number of places as the number of zeros. I have 1 0. I move it to the left 1 place, and look what number I come up with, 254, exactly the one that we got. That's kind of a neat little trick, isn't it? That's a great divisibility by 10 trick. Move the decimal to the left. The number of times you see is the zeros. Now with those little tricks under our belt, we're going to do some double-digit divisors. And when I do a double-digit divisor, one of the tricks that I use is I look at my divisor and I do an approximation. So if you haven't listened to my rounding video, then this might be the time to go refresh yourself on rounding. So I'm going to look at this as not 17 but as 20. So I'm going to be thinking in terms of dividing by 20, because double-digit division we're having a lot more problems with, because we don't know all of our facts for 2, 3, 4-digit numbers, so it makes it harder. So I look at this and I say, okay, well, 17's 20. That's what I'm thinking in my mind. So 20 would go into 24 how many times? 1 time. And that gives me a place to start. Now, it's not always the place that's going to work. It will this time, absolutely. It's not always the place that will actually work, but it gives me a place to start from, and then I can go up or down by 1 as needed, depending upon how small or how large this product is. 1 times 17 is 17. And so then I subtract. So now I have 24 minus 17. So I'm going to borrow here. 14 minus 7, which is 7, and I'm going to bring down the 6. Okay, now 17 goes into 76. I'm thinking in my mind this is 20, right? And this is almost 80. And that's another little trick I can use there. So how many times would 20 go into 80? Well, 20 would go into 84 times, right? So 20 and 80, and again, I'm just focusing here. So that's why the trick helps us. So 2 will go into 84 times. So then I'm going to go over here and I'm going to multiply 17 times 4 so that I can check that out. So I have 28, carry the 2, and 4 times 1 plus 2, which is 68. And that looks like it's going to get me reasonably close. And so I put in the 4. 4 times 17 is 68, and then I do the subtraction. So here we go, 16 minus 8 is 8. By the way, if what you get as a remainder here is bigger than your divisor, that means your quotient wasn't quite big enough. You need to erase it, bump it up to the next value, re-multiply and resubtract. That's how you know. All right, so now the 5 comes down and we divide again. So I'm going to say again, okay, well, if this were 80-ish and that were 20, then I get the 68. Well, the question is maybe is that too small? So there's no harm. I've already got times the 4. Why don't I just pop off times 5 here and see? So we have 5 and then carry the 3, and that is exactly 85. And so I put in 5 just like that, and I've got the 5 times 17, which is 85, and then I do a subtract. And what you would have seen here, and I'm going to do this in red just so you can see, say I went with the 4, I thought, oh, that's close enough. So I would have gotten 85, and I would have subtracted 68, right? And I would have had to have borrowed here, and that would have given me a 7, and 7 minus 6 is 1. And you see this is just the same number as this, or if it had been larger. And what that tells me is that the divisor number, if I would have used the 4 here, right, that's based upon the 4, if I would have used that it wasn't a big enough number and that I really needed to go to the 5. It's important that you hear that and you see that, so that's why I've mentioned it. Okay, now let's go with one that's not quite as easy. 3,598 divided by 21. Oops, maybe you ought to try this one on your own. So why don't you try it and see how it goes. Pause that video and go ahead and give it a try. Can't hurt. All right, so here we go. 21 goes into 35 how many times? Well, this is about 20, right? I think to myself, oh, this is only 20. So that would only go in there one time. So 1 times 21 is 21. And 5 minus 1 is 4. 3 minus 1, or 2 is 1. 14 is definitely less than 21, so we're okay. Don't worry about it. Now I'm going to bring down the 9. And so now I'm looking at how many times will 20 go into 149? Remember when we talked about the 20 and the 80 in the last example? So what I'm really thinking here is how many times will this happen? Because that's about 1/5-ish, right? And I'm really thinking about how many times will 2 go into 15? Well, it will go in there a little over 7 times, right? It's over 7. So that's where I'm going to start. That's where the estimating helps me. So I'm going to say 7 times here. And so now I have 147. Oh yeah, that's close, right? And it's close enough. So I'm going to put in 7. 7 times 21 is 147. And then I subtract. And then I subtract this, I get 2, and then I bring down the 8, and then 21 will go into 28 one time. So 1 times 21 is 21. Subtract, and I'm going to get 7, and then I'm going to start adding zeros out here, right? And so I'll bring down. And so now I say, okay, well, 20 will go into 70 how many times? Well, that would be about 3, wouldn't it? So let's try 3 and see what I get. So this looks like 63. 3 times 1, 2 times 3. So 63. So my decimal comes up because I'm passing it, right? So here's my 3, and this is 63. And then I subtract and I get 7 again, and I bring down the 0. Well, that was just like the last time. And I do it again, and pretty soon I begin feeling like a broken record. Gosh, I've done it again. And that is because this is another one of those non-terminating repeating decimals. So I'm going to put a bar over a couple of the 3's to show that those are going to repeat, going on and on and on. All right, now this one, maybe you should try this one on your own and see how it goes. Pause the video and then come back and take a look and see if you've got it. Okay, you should find this one not quite as challenging, I hope. So if you say, okay, 63 will go into 27, 2-digit, 2-digit. Nope, that's not big enough, right? So I'm going to have to go to 3. So I'm going to call this being just about 60, right? And I'm going to call this being just about 2800. And so I'm going to be looking here, and I'm going to be looking here. Well, 6 would go into 28 how many times? 4 times, right? So that's where I'm going to start. I'm going to start out with 63 times 4. So 3 times 4 is 12, carry the 1, and that puts me at 252. So we'll try that. So here's the 4. Remember, lining up is really important. That's what number we were dividing into. That's where it goes. 252 here, and then subtract. So we have 1, and then 2, and that's it. And see, 21 is definitely less than 63, so we're okay. Now I'm going to add in some zeros out here, put the decimal in as I go across it, and bring down. Now the decimal doesn't come down into these numbers that you're creating to divide. So 63 and how many times? So this is about 20, right? 6 will go into about 23 times. So we try that. That's 9, and that's 189.